Yesterday we talked about some of our plans for the holiday weekend, but I say we start this morning out with just saying some things that we're thankful for. Anybody? What are you all thankful for? I'm thankful for my family. I'm thankful for my coffee. Thankful for a warm place to be this morning. Minecraft. That's awesome. My family and your friends, Kylie, that's good. What else are we thankful for? Anybody? You're living, that's good. I always feel like I underestimate like my health until I feel sick, right? And then you're like, oh, I took all of that for granted. Yeah, food, shelter, heat and air, some cool educational opportunities you've had. That's great. Coffee would count as life. I would agree with that. I'm also thankful for my health. So it's no fun to not feel good. Good best friends that are like sisters. Absolutely. Good. Anybody else? It's always a good way to start the day. Yes. I love Thanksgiving. It might be one of my favorite days of the whole year. My family used to all live here locally. We don't live here locally, but I've been close with my cousins for my entire life. So they're all coming into town, and I just like nothing feels better to me than eating like home cooked, feel good family food and just sitting around and spending time with them. I love that. Mashed potatoes and stuffing. I like food, so I can't say that there's anything that I don't particularly love. Not huge into cranberry sauce. But other than that, I like all the things. Are you guys pie eaters? Do you guys like pies? My little sister is a very good baker. Yes, Thomas, apple pie, macaroni, banana pudding, sweet potato pie. Yes. My sister, she makes what she's gonna do, butterscotch, old-fashioned cream, peanut butter, pecan pie. What else? She is such a good baker. Ooh, strawberry rhubarb. So good. You could have a whole lesson just on pies. Okay, do you say pecan or pecan? That's the ultimate, is the ultimate, like, how do you say, I say pecan. Yes. Chris, do you say pecan or pecan? Pecan. Milo, do you say pecan or pecan? Pecan. So funny. How do you say that, JB? I had to hear this. Are you able to use your mic?
I say it pecking.
Kind of like bacon with a P. Oh, and Caden's got a Thanksgiving dance for us this morning. I
Dear
love it.
God, he's doing the Pizzotski kick.
That is hysterical. We are festive around here. I don't think I've heard it pronounced like that either. You guys are so much fun. I love it. What do you say?
I got coffee.
What is that?
I got coffee, and I'm happy.
Yes. JB's got his coffee. Jana, are you in the house today? Alex is here.
Hey, Alex. Weekly reset today.
That's awesome. Yeah, Jana says, huh? Jana's thankful for music. Yeah, Jana, we need to hear one of your mixes again soon. Okay, when I get back from testing, we are restarting music, your mixes and cadence dances. I miss all of our.
Can I have an idea for next week? Can I have an idea when we come back?
What?
Can I have an idea? Can I give an idea for when we come back?
Yeah.
For the music. So JB has a Russian accent, except the only song on Just Dance I have gotten all correct perfects on is Rasputin. So I am willing to challenge JB to a Russian dance.
Ooh, I like it. I like it. JB challenge accepted. JB's not sure about the dance. Maybe JB will narrate the dance. We'll let Kaden do the dance and JB narrate it. And Jana will give us the mix. I'm pumped about this. Jana, are you losing confidence in your music?
Either Rasputin or A Little Party Never Killed Nobody. It's one of those two.
I like it. Awesome. Well, let's get this lesson underway and get you guys one step closer to your break, okay? Today is our last day before Thanksgiving break. We will be out then. All right, we will be out Wednesday, Thursday, Friday. Next Monday, you will have class. I will not be your teacher. Mrs. Palmer will be your teacher. She is wonderful. You will love her. You may never want me back again. She's that great. So, yes, you'll look forward to spending I think 5 sessions with her, and then I'll be back. Kaden, what are you showing us? Did you get new socks?
I'm sniffing the socks because I just got all this new clothes because I have all my socks have holes in them. I'm smelling the socks because I want to make sure they smell good. I also got new jeans and new pajamas. I'm going to sadly to a funeral soon, so I had to get new pants and stuff.
Oh, I'm sorry about that, but new socks are good. Balances out the funeral parts. Oh, well, great. That's awesome to have some new clothes. All right. You see that as we move through our unit, guys, look, we've got some more analyzing goals today as we go through our lesson. Anybody want to read these? What are we going to do? What in the world are we going to do with our last 45 minutes of class? Who can read what in the world we're doing today?
Okay, dears, I can do it, of course, because apparently the Russians is trying to do hardest communism, so of course the transatlantic can do it. And what if there was a slide? JB, Russian, your internet is not that great, dear. What does sex-linked inheritance mean? Can you give 2 examples of sex-linked traits found in humans? Can you complete a sex-linked trait Punnett square, dears?
Perfect. So today we are going to look at what some traits are. All right. So we've been talking about traits that we inherit from our parents. And yesterday we talked about how usually we have one dominant and one recessive. And anytime there's a dominant allele present, you squash that recessive allele and it doesn't become expressed. Yesterday, we looked at two exceptions to the rule being incomplete dominance and codominance. Incomplete dominance was what? Can you help me? You're okay. Incomplete. If it's incomplete, what does that mean? Yes, Maria. Yes. That means the phenotypes blend. That was the example of the red and the white flower having offspring that were pink. Perfect, Kaden. Yes, or mixed. What about codominance? Codominance. What happens in a codominant situation? Yes. So you have two alleles, and instead of one trumping the other, they're both expressed equally, meaning that if there was a red flower and a white flower that were crossed, all right, they would have offspring that have both red and white petals, all right? You don't see that blending of the petals. Oh, pardon me, man. Mrs. Rittenhouse needs to like chug her coffee a little faster in the morning. So, how cool is this? We each have one of these probably on file somewhere. If not, we could. What this is right here is a picture of your DNA in its chromosome form. All right, so humans, we have 23 pairs. So remember how we talked about how our chromosomes line up with their pair in mitosis at the middle? There are 23 pairs of chromosomes in humans. So sometimes we'll look at your DNA. Sometimes they can do this with babies, like when Ren and Milo were born or conceived. I could have a DNA test where they went in and would get a sample of some fluid from their amniotic fluid, and they could take their DNA and they would do this. They would pull the chromosomes out and pair them together and look at their chromosomes and look for abnormalities. And they could tell me certain things about the girls based on their chromosomes. All right. So a karyotype is a review or a picture of your chromosomes. Humans have 23 pairs, and look, this very last pair down here are our sex chromosomes. All right, they are what determine our gender. All right, if you are a female, all right, if you are a female, your 23rd chromosomes are XX. If you're female, type XX in chat. All right, this is your gender determining chromosome. So this tells you whether or not, good, you are male or female based on your chromosome. Private chat me about it, Sarah. All right, if you are a male, your chromosomes read XY. XY. Okay. So if you are a male, your male gender determining chromosomes so there are some. So Izzy's question was, what if someone is born a hermaphrodite? Serious question. Hermaphrodite would be a sex linked, and that's kind of what we're going to talk about today. In some extent, others are going to go into next chapter. There would be sometimes there are extra chromosomes, okay, where you'll have like two X's and a Y. Does that make sense? You could technically have, or if this, I know that, I know it is sad though, guys. These are genetic disorders, all right? So sometimes we have extra DNA. Some of us are born with extra DNA where you'll have an extra chromosome, an extra part of a chromosome, a missing part of a chromosome. All right, so if you know someone that has Down syndrome, okay? All right, that is called trisomy 21. And that means not this 23rd set, but if you go back to the 21st set, they have an extra, that's the tri. They have an extra piece of DNA. All right. And so it really actually, you would think that it would benefit you to have more versus less. And both situations that's what they're looking at actually when you go in. And I didn't have it done with my girls just because I decided I'm going to love this baby no matter what we're dealing with, and I don't want to stress about it up until the day they're born. But a lot of times if you have people maybe in your family that have genetic disorders, they're very serious situations. A lot of times they come with reduced life expectancy and honestly some troubling situations. So it does sound comical, but it really is. And I know there was some jokes and unfortunately sometimes social media takes it in directions maybe that it shouldn't. But we're going to actually get into that more next unit, and we're going to talk about mutations. Right? What happens when our cells don't divide the way they're supposed to and mistakes are made? We get some of these genetic disorders or even sex-linked disorders. And I'm just going to address it because there is a thing with where people are choosing to be a different gender than they are genetically born. And that is a thing, whether we agree or disagree with that or have feelings about that or whatever else, we're not going to bring that into conversation today, okay? We're going to be respectful of everyone here. But you were all born with a 23rd set of chromosomes. And when you were born, there were XX or XY. Or unfortunately, we can have some mutations that occur, all right? And thanks to just like things like IVF that helped me have baby Ren, there are things that we can help do to help with some of those situations, all right? Medical situations. So hopefully I covered all the questions about that, whether or not we switch with the gender that we associate ourselves with later on in life. We all have a 23rd chromosome that we are born with that we have an identified biological gender as. All right. So hopefully I tastefully covered that for everyone and made that as comfortable as possible. All right, so when we talk about these sex-linked traits, we're talking about that 23rd pair. I find this super cool. Look at this, guys. So if you are a male or were born with an XY chromosome, this is what your chromosomes look like. Check this out. Your Y chromosome is actually much shorter than the X. How crazy is that? See that, guys? This is what your DNA looks like. Caden is finally. He doesn't understand why his Y chromosome is so small. He's not pleased with this. Believe it or not, there are certain traits that you'll find that are associated between males and females. One of that for men would be hemophilia. Another one would be colorblind. Has anyone joked with you about being colorblind? Seriously, has anybody? It's a real thing. It is a real thing. Chris, do you think you're colorblind? You're a guy at work. He only saw blues and greens. All right. It is much more common in men. You're right. Brianna's right on it. He only actually could see blues and greens. How crazy is that? So if you have been teased about being colorblind and you are a male, it is a genetic thing. It is absolutely a genetic thing. It is a genetic trait that is linked to the Y chromosome. See, it really may be a thing, JB. So the next time if your parents tease you and they you come down dressed and they're like, what are you thinking when you put that on? You can just blame it on your genes, guys. See, maybe it is, JB. It could be genetic, and if he has it, he could have passed it to you very easily. So crazy. That's what I love about studying genetics, because all these things that you might not have realized are things, or things that you might have really inherited are things that you could have inherited. All right, so let's look at this one. We're going to look at what we would be doing in a Punnett square. Is it possible for a female? I believe it is possible for a female. So look at this. This is the interesting thing. So for some of those things, because females have a longer chromosome, so we have two X's. So both of our chromosomes are long. See this? Some of the things that are coded on this X chromosome, like I believe it is with seeing color, we have the ability to get another allele for. Does that make sense? We get two alleles for that trait, so that recessive allele could easily be trumped. For men, you are more susceptible to some sex-linked traits because of that small Y chromosome. All right? You don't have some of the alleles here that women do. Basically, we get two chances at some traits that you only get one chance at. Does that make sense? Yeah, isn't that crazy? Yeah. Caden's like, go figure. We got the short end of the stick over here. Awesome. Let's keep going on. All right. So let's look at Punnett squares. Punnett squares. Let's keep chat on task because I'm getting distracted over there. All right. Because females have two copies of an X. See, this is what we're talking about, X chromosome. We have certain traits that are hidden that men do not. Right? So we get the ability to mask them. Right? Whereas you're seeing down here, since males only have one X chromosome, they don't have that opportunity to get that second allele and not have expressed. So when we do a sex link cross, you're going to see these little letters. Everybody see these letters? Use your pointers and point to these little exponent letters. Good. Perfect. So what these are the basically the alleles. All right. So we're looking here. When you see that we're crossing genders, and that hold on, I'm getting distracted in chat. Yes. You're looking at the letters. Good. Can you see the numbers in here? Good. 12 to 42. I think that's a 71 and a 6. Cool. Yes. Awesome. Yeah, it's testing your eyes for all the color. So this is what a female with normal vision is going to look like. Big N is for normal, right? If you're a male and you have normal vision, this is what your genotype would look like. All right, you have your X and your Y chromosome and a big N. Now, you can be a female and carry that allele for color blindness. So if I could be this, all right, even though I can see all of those colors and determine that, I personally don't know if I'm homozygous or heterozygous for normal vision. Okay? I could be either one of these and still see color. Now, I could be, look, this is our colorblind female would be very unlucky because she would be receiving that recessive allele in both of her sex chromosomes. All right. If you are a male, look, you only get one chance. So if you are colorblind, you have the recessive allele or the recessive trait. Right? So you only have two choices if you're a dude. If you know that you can see color, and someone can confirm that, all right, then this will be your genotype. All right, if you cannot see these colors, then this would be your genotype. You know you have that recessive allele for colorblindness. And you could also, and if you have offspring, what does that mean? If you have an offspring, you have the possibility of passing that on to them. How cool is that? So Caden, you could see all of those, right?
Yeah.
Yes. Good, good, good. Awesome. Any questions about this? This is the stuff that I find super intriguing. All right, let's keep moving. So this is going, Izzy's seriously ready to go get her eyes checked. She's like, I need to figure this out. It's gonna drive her nuts. We know what Izzy's gonna do over the holiday break. She'll be a thigh doctor. That's awesome. So Alex and Kaden and JB, you know that you have that dominant gene. JB will be eating cheese. All right. Too bad we're not in person, JB. You could have brought us in like a giant cheese ball before the holiday break. Oh, he said he couldn't see the 2 in the second one. So maybe he is. All right, let's read this. Anyone want to read this for me? About color blindness. Let's read through and try to solve this Punnett square. Anyone? That's okay, Alex. Anybody else? JB, Kaden, Jana, Brianna?
Sure. Okay. Color blindness is a sex-linked trait that is carried onto the X chromosome. Red-green color blindness is caused by the recessive allele N. It's carried on the X chromosome X to the square, X to the power N. When the X chromosome carries the dominant allele capital N, then it is written as X power capital N. A woman with normal vision whose father was colorblind is married to what? A woman with normal vision whose father was colorblind, so the father is married to a man whose mother was colorblind.
That's a lot. So a woman with normal vision whose father was colorblind. Okay, so why do we care about her dad? Yes, Brianna, perfect. So the woman we need to know that because that tells us that she's heterozygous, right? Because the dad was colorblind. So we know that the only allele that her dad could pass to her would be, I know, right? Tricky. So we know the only thing that he could give her is that lowercase n. So we need to do x. This is going to be, I know, it makes it a little trickier to the lowercase n. But we know she can see color, so that tells us that she is heterozygous. So she would be x little n, x to the big N. All right. And it says she's married to a man whose mother is colorblind. Why does that matter? Why does it matter what his mom is? What does his mom have to be if she is colorblind? For a woman to be colorblind, she has to be like double unlucky, right? Yes. So she has to give him, right, a man whose mother was colorblind. So that means she's only going to give him the lowercase n. Man is married to a man whose mother was colorblind. But do we know if he's colorblind? Right? Because his dad could have, I guess it doesn't matter, but no, because his dad so he would be colorblind, I think is what that is trying to tell us. So he would be X because he's getting the X from his mom. Oh, he would be X, Y, but his X would be X to the little n. All right, so X. Oh, crud. But see how this becomes much more of an analysis because we have to go through everything we know about, no, come back, X, about being recessive and dominant and all of that. So this is going to be X to the little n. If I could type this, it would be so much easier. Or write, but I can't write on this thing very well. Okay, so X to the little n and then the Y. We know that that trait isn't covered, like, on the Y chromosome. So can someone help me? Can someone help me? Do this cross. Okay. It's the same way, right? Dad drops down, mom moves over. Yes, it does pass on. Sure, you don't have to talk. So what would this first box be, Alex? You just type it to me and then we'll type it in the chat. Box 1. What would that be? I just have to keep moving my... Good. X to the little n. And then X. I see one of them up there. To the little n. Good. What about box 2? Can you do box 2 for me? Mom moves over. Dad drops down. Yes. So X to the little n, Y. Good. Same down here, box 3. X to the big N, X to the little n. Perfect. Last but not least, box 4. X to the big N, Y. Awesome. Whoop, whoop. All right, now who can tell me? Who can help me? Alex did a fantastic job completing that. Let's look through this. Who can tell me the gender of box 1, XX? What is this individual genotype going to go for it? JB, you want to get on your mic? Nope, it ain't a dude. You're right. It is a girl. Is she colorblind?
Yep.
Yes. All right, what about the second box, JB?
That's a dude.
It's a dude. Is he colorblind or not?
Yep.
He is. He has that little N on his Y chromosome. What about box 3?
Ain't colorblind, but it ain't a dude.
Good. It is a female, and she is not colorblind. And last but not least, box 4.
That second guy ain't colorblind.
Good. It's a second guy, and he is not colorblind. See, you guys are rock stars. And I love that y'all did it together and participated. You've got this. Good job, Mila. Mila's doing her work too. Wonderful. Your messages didn't go through really. I love it. I think it's working. Oh, Emma says hi, Mila. She says, hi, Emma. She's waving at you. Awesome. So this is wonderful. This is exactly what you do. Now, somebody said it earlier, I forget who said it. Does this add a little bit more to the Punnett score? Does it require a little bit more thinking and analyzing? It does. It does, but that's why we're doing it last, right? Yeah, it's not terrible. It just makes you think a step behind. So like I said, why are they talking about my father? If you're reading a question like this on your end of course exam in the spring, and it's talking about your father or your mother, why are they telling you that? Well, they're telling you that you probably need to think that direction with your inheritance. I know we are right on time, Diamond. Thank you. All right. That is fine. How do we feel today about this quick poll? How do we feel about it? I feel like you know what sex-linked inheritance is. It is what? When a characteristic is tied to your sex-determining chromosome. Thank you, Diamond. You too. Can you give 2 examples of sex-linked traits? Talked about colorblindness, hemophilia. And you definitely completed a Punnett score. Look at that. You guys are overwhelmingly feeling confident about that. Don't forget to do something today before you leave to make this stick. All right. There is practice questions. I did not make them mandatory. We're going off onto a break. I'd prefer you do a grade book check. Make sure your grade is to passing. If you haven't passed, you're going to hear from me. Okay? Please check your grades. We don't want you to come to class, know this all, and not get a passing score. Thank you so much. You guys are so sweet. I'm going to miss you all during testing. I'll still be responding to emails. I might be a little slower than normal. Have an amazing week off. Have an amazing Thanksgiving break. I know it's some of you are looking forward to it. It might be a change for some of you. It might be a hard season, but please know I'm thinking of each of you and that I'm thankful. Nope, tomorrow you do not. You are off tomorrow, Miss Ava. Yes, I'm thankful for a break and I'm thankful for each of you. Each one of you really do mean a lot to my heart. Have a great break, and I will see you all soon.